Hi. Today we're going to be talking about proving function inverses. So let's say you have two inverse functions, or you have two functions that you think might be inverses. How do you know? Is there a way you can test and prove, yes, these two functions are inverses? Well, yes, there is a way. There's two conditions that if they're true, you know two functions are inverses. And if they're not true, you know they're not. Right? So let's say I have a function f, and g. Right? If f of g of x is equal to x for all x in the domain of g, right? So all acceptable x values of g, and g of f of x equals x for all x in the domain of f, or all acceptable x values for f, right? If f of g of x equals x and g of f of x equals x, then the functions are inverses. And you might say, well, doesn't that seem kind of random? But it makes sense, right? This is because if f and g are inverses, right, composing them, making them composite functions of any of them will cause the two functions to sort of cancel out, right? Every input returns that output. So what you get back is your original input. We call this relationship the identity function. So let's put this into use. Let's, given some f's and g's, figure out, are they inverses? Right? So let's do one. Let's say f of x is equal to x plus 1 over 3. And g of x is equal to 3x minus 1. Let's test it. So first, f of g of x. Right, so we're going to plug in this entire term in for our x, right? So that's 3x minus 1 plus 1 over 3. Those two cancel out. 3x over 3. We're left with x. So far, so good. We plugged in this. We got x. That's 1/2 of our identity function done. Now for g of f of x. Right? We're going to take g of x and plug in this entire thing into here. Right? So 3 times x plus 1 divided by 3 minus 1. Those 3's cancel out. We're left with x plus 1 minus 1. That cancels out. We're left with x. Right? So g of f of x also equals x. These both equal x. We have an inverse. We know that for a fact. We can prove it just then and there. Right? Let's do this again. Let's say this time f of x is 5x minus 7. And g of x is x over 5 plus 7. Right? So f of g of x first. This should be equal to x if they're inverses. Right? So let's plug in this. 5 times x divided by 5 plus 7 minus 7. Let's figure out that 5. This becomes x. This becomes 35. 35 minus 7 is x plus 28. So this equals x plus 28, not x. Not a good sign. And of course, if we try to do g of f of x, you might imagine what we're getting now. That's 5x minus 7, because that's f of x, over 5 minus 7. Right? So that's the same thing as x minus 7/5. Plus 7, which is the same thing as x plus 28/5. And now we see we definitely don't have inverse functions, because when we use our identities, we got two different values. X plus 28 is not the same as x plus 28/5. And just by doing that, we know these functions are not inverses. If this was x and this was x, they'd be inverses, but they're not. They're x plus 28 and x plus 28/5. So by doing that, we confirm that these functions are inverses. So whenever you're presented with inverses, whenever you've done the math and found a function's inverse, but we want to be sure, remember the identity rule, right? F of g of x and g of f of x. They should both be equal to x, because if they are, they're inverses. If either one of them or both aren't equal to x, they are not inverses. And that's how we prove that certain functions are inverses. I hope you found that helpful, and I hope you have a great day.